You can't take a picture of Neptune's unusual magnetosphere, which is the bubble that the planet's magnetic field carves into the solar wind, because it's invisible to the naked eye. Everything we know about it is derived from local measurements that the spacecraft Voyager made as it flew through. Understanding the functioning of Neptune's magnetosphere is important, as it gives us insight into what goes on in the planet's interior. For Neptune to have a magnetic field, it must have two things. Firstly, a fluid and electrically conductive region within the planet's interior, and secondly, an energy source that sets the fluid interior in motion and keeps it moving. Neptune's magnetic field is tilted 47 degrees off its rotational axis and is offset approximately 13,500 kilometers off its physical center. The strong electrical currents must therefore be produced closer to the surface than Earth. Depending on which equator is being measured, the strength of the magnetic field varies by a factor of 10. Because of its unusual orientation and the tilt of the planet's rotational axis, Neptune's magnetic field goes through dramatic changes as the planet rotates in the solar wind. Scientists now think that the extreme orientation may be characteristic of flows in the planet's interior. The convective fluid within the planet is moving at a greater speed than the planet's core, which is believed to cause the orientation. Neptune's magnetic field provides an insight to the planet's structure and behavior. New simulations allow us to see what Neptune's magnetosphere is actually like. In this simulation, you can see the irregularity of the field caused due to its unusual tilt and rotational axis. The most reliable indicator of the internal rotational period of the planet are the periodic radio waves generated by the magnetic field. Voyager 2's instruments measured these waves and determined that one day on Neptune lasts 16 hours and 7 minutes. The magnetosphere also gives us an insight into the thermosphere, which remains a partial mystery. Although Neptune is distant from the Sun, the thermosphere is as hot as 750 Kelvin. One candidate for the heating mechanism is the atmospheric interactions with ions in the planet's magnetic field. I hope this has given you a larger insight into the complexity of our furthest planet. Thank you.